Today, we will look at some of the properties of Laplace transform. Properties of LTE. So, the first property is called as the S domain shift. So, the statement is like this: we have a signal f of t whose Laplace transform is f of s. If I multiply this signal f of t in the time domain by e to the at into f of t, then the Laplace transform of this function is going to change as f of s minus a. So we can see f of s becomes f of s minus a, and because of that reason we are going to call this as s domain shift. We'll prove this. We'll start from f of s, which is equal to integral 0 to infinity. This is the function f of t into e to the minus st dt. This is the f of s. How to obtain f of s from f of t, the standard equation of Laplace transform. Now I start from the left hand side and I try to find the Laplace of that. So I want to find the Laplace transform of e to the at into f of t is nothing but integral 0 to infinity the function e to the at f of t into e to the minus st dt. So we can say from this I can club the exponential terms, keep f of t as it is, into e to the power. If I take minus outside, this becomes s minus a times t dt. So when I had the term s over here, we used to call the whole integral as f of s. But now inside this bracket, I don't have s, but I have s minus a. So this is nothing but the capital F of s minus a is the answer. So there is another way to represent the same property, that is instead of e to the power atf of t, right? Okay, let's make an entry in our table like this: e to the at f of t will have the Laplace transform, that is f of s minus a. At the same time, if you write e to the minus at into f of t, this function will have Laplace as capital F of s plus a. So both are shifting properties. Shifting happens in the s domain. Okay, let's go to the next property. So this is called as derivative of s domain. So in the s domain, we are going to see a differentiation term now. So the statement of the property is like this: f of t has a Laplace transform f of s, then t to the power n into f of t will have its Laplace transform as minus 1 to the power n into this is d to the power n by ds to the power n of f of s. So this is the statement. Now we'll go to the proof. So we start from what we know, that is if you know the f of t, we can find the f of s like this. So f of s is equal to integral 0 to infinity. This is f of t into e to the minus st dt. So let us differentiate on both sides. Differentiating with respect to s, both sides. So left hand side, I'm going to write the d by ds of f of s should be equal to, on the right hand side, this is 0 to infinity. We can perform the differentiation of only the term containing s. So f of t remains as it is into this is d by ds of e to the minus st dt. So this is equal to integral 0 to infinity f of t we have. So f of t remains as it is, e to the minus st becomes minus t into e to the power minus st dt. Now this means what? If I have a function called minus t into f of t, its Laplace is going to be the d by ds of f of s. This implies I can directly write minus t into f of t will have the Laplace transform as d by ds, d by ds of f of s. This also implies, simply I write t into f of t will have its Laplace as minus 1 into the d by ds of f of s. Simply I am taking the minus to the other side. So this means if in the given statement of the property, right, if you put n equal to minus 1, n equal to, sorry, not minus 1, plus 1, if you put n equal to plus 1, right, we are able to verify the results. Okay, so we can write this verifies the result for n equal to 1. Okay, next we try to make sure that the same result holds good for any value k. Okay, so for that we need to make an assumption that assuming that this result is true for any n is equal to k, right? That means I can write it in this fashion, that is Laplace transform of this is t to the power k. Okay, this is a k, t to the power k into f of t is nothing but this is minus 1 to the power k into this is d power k by dsk of say f of s. We assume like this, right? Now in order to obtain the value, this whole equation is true for any value of n, right? Any other value n, we have to make sure that the given function, given equation is true for any value k plus 1. Okay, so we try to differentiate. Therefore, differentiating again with respect to s, right? I'll write the right hand side part on the left first. Okay, that is so minus 1 to the k. So this is d to the k plus 1 divided by ds to the k plus 1 of f of s is nothing but, so left hand side I replace it by 0 to infinity, right? This is, there is a t to the power k into f of t, this is already present, right? Into this is derivative of d by ds, this is d by ds of e to the minus st dt. So this is now becomes equal to integral 0 to infinity, this is t to the k into f of t into derivative is minus of 1 into t into e to the power minus st dt. So what I do, I take the negative of the 1 to the other side. So that means this implies minus 1 to the power, there is a k, becomes k plus 1 into d to the k plus 1 by ds to the k plus 1 of this f of s is equal to, this is integral 0 to infinity, we have t to the k and one more t coming up, this is t to the power k plus 1 into f of t into e to the power minus st dt. So this has a specific meaning now, so that is nothing but this is the Laplace transform of t to the k plus 1 into f of t. Okay, now the given equation is true for any value k is equal, I can say that this is true for any value n is equal to k plus 1. So any k you take plus 1 will be satisfying this. So therefore I can call this as equation 1. 1 is true for any n equals to k plus 1. Therefore this means I can rewrite the whole thing in terms of n itself, I don't have to retain the k. Okay, so now just see this, this implies Laplace transform of, this is t to the n into f of t should be equals to minus 1 to the power n, this is d to the n by ds to the n of the f of s is the proof. Next property, this is property number 3. This property is said to be integration of S domain. So on the right hand side, we are going to see that there will be an integration. So the statement of the property is as follows. If f of t has the Laplace transform given by capital F of S, then the f of t divided by t will have a Laplace transform, that is integral from S to infinity. This is f of s ds. Okay, so now let's start with the proof. We know that the f of s is equal to integral 0 to infinity f of t e to the minus st dt, right? So now I integrate on both the sides, right? Integrating both sides. So that is integral s to infinity f of s ds should be equal to, right? This is equal to, now what happens to the right is you get double integrations. First one is integral s to infinity, and the term which is already existing there, that is integral 0 to infinity. This is f of t into e to the minus st dt. So on the outside I have to write a ds. Right, now what I perform is a very standard technique in integration. It is called as changing the order of the integration. So how to do that? Bring the integral which is present on inside of the brackets to the outside, that is integral 0 to infinity, right? And bring the term which has the integral s to infinity to the inside, okay, that is s to infinity, right? We'll write it in this way now. So this is e to the minus st into f of t ds dt. So inner brackets are applicable for s terms, then outer brackets, outer integration is applicable for the terms containing t. That's why it is called as changing the order of integration. Now, in order to solve this integral, what I am going to do, I will keep the 0 to infinity, that integral, as it is. Then you can simply integrate with respect to s. This is e to the minus st divided by minus t into f of t dt. And I need to make a substitution from s to infinity. So when we perform the substitution of the limits, I'm going to get integral 0 to infinity, right? So when you put infinity to e to the power minus st at the location of s, this becomes e to the minus infinity, which is 0. Minus, when you put s over there, it remains as it is. So this is e to the minus st divided by minus t, right, into f of t dt. So this means now I can rewrite this. This is minus of minus will cancel. This will become plus. So I can write this as integral 0 to infinity. This is f of t by t is the first term into e to the minus st dt. So now you see this can be written as this is equal to Laplace transform of f of t by t. So that itself is the left hand side. So we started from the RHS, that is we started from s to infinity f of s ds. We started from here and we ended up over here. So that is the proof. Okay, then let's go to another property. This is property number 4. This says integration on time domain. So S domain is on the right hand side, that is Laplace. Time domain is our normal signal or normal function, whatever we write in terms of t. Okay, so this says the statement is if f of t has Laplace transform, that is f of s, then integral 0 to t f of t dt will have the corresponding Laplace transform as f of s divided by s. F of s divided by s. Okay, now we start with the proof. So that is Laplace of f of t, that is f of s. So if I want to start writing this particular function in the following notation, so that is Laplace transform of, okay, this is integral 0 to t f of t dt, right, should be equal to, this is integral 0 to infinity into integral 0 to t f of t dt into e to the minus st dt. All right, now so what we are going to do now is let us try to integrate this by parts, because we have two functions over here. So this is equal to, so integrating by parts in the sense, keep the first function as it is. This is the first function, whatever is inside the bracket, so we'll keep it as it is, that is integral 0 to t f of t dt is my first function. I keep it as it is. Different, so I need to integrate the second function, that is e to the minus st divided by minus s. So in order to make a substitution for this from 0 to infinity, this will be done in the next step. Okay, so minus, I have to write the answer of the integral as it is, so that is integral 0 to infinity, this is e to the minus st divided by minus s into differentiation of the first function. You see that this function has an integral. When you take a differentiation, they will cancel out and you are left with only f of t dt. Okay, so this means, so when you put infinity to the first this term here, right, e to the minus infinity, which is 0. Okay, when you put 0 to this term, right, I'm substituting for t is equal to 0, right, the is integral 0 to 0 f of function. That function gives me a 0. So you see that this is 0 minus 0 initially. So plus, minus of minus have been cancelled and you have a plus here. So there is a 1 by s into 0 to infinity. This is f of t e to the minus st dt. So what is that? This is nothing but f of s. So I have f of s divided by s. So that's the overall proof. So now we will start solving problems based on these properties. Okay, so okay, now the first problem based on properties. F of t is equal to, this is e to the minus 2t into 2 times cos 5t minus sine 5t. Okay, so therefore I can directly write f of s is equal to, right, whenever I have e to the minus e to the power minus at, right, I know that the function becomes f of s plus a, right? So I should write the individual f of s other than e to the minus 2t, and I should replace s by s plus a. That was the first shifting property. So what I do, I write for the first term, that is 2 into, it's a cos term, so this is s divided by s square plus a square, a is 5 here, so 25. Okay, then I have minus sine 80 is a divided by, so a is 5 divided by s square plus 25. So actually I can club this. This is the Laplace of our 2 cos phi t minus sine phi t. So this is equal to 2s minus 5 divided by, this is s square plus 25. Alright, this is the first half of the answer, but I need to make a change. This is s should be replaced by s plus 2, and even this s should be replaced by s plus 2. So after clubbing, it remains same. S should be replaced by s plus 2, because it's the function is actually having a multiplier e to the power minus 2t. So therefore this is equal to, replace now. So this is 2 into s plus 2 minus 5 whole divided by, this is s plus 2 the whole square plus 25. Alright, so let us expand this. So this becomes 2s plus 4 minus 5 whole divided by s square plus 4s plus 4 plus 25. So the final answer, f of s is equal to 2s minus 1 whole divided by s square plus 4s plus 29 is the required answer. Alright, moving on to the next problem. This is f of t is equal to e to the minus t into cos square of 3t. So first let us start with the cos term and let's represent that as a 1 plus cos 2 theta format, then we'll take its Laplace, then we'll apply the e to the minus into this. Okay, so let's start with the cos function. So cos square 3t can be substituted as, right, this is 1 plus cos 2 theta, so 1 plus cos 3 into 2 is 6t divided by 2, right? Now if this is a function, right, I can take its Laplace, right, and I can write this as, there is a 1 by 2 which is like, which I want to keep it outside. So 1 plus cos function is there, 1 becomes 1 by s, and cos becomes, this is s divided by s square plus 36, s square plus a square, right? If this is the Laplace of just cos square term, then according to the rule, if you multiply by this function by e to the minus t into cos square t, what should happen to the Laplace? Original Laplace, whatever was there, you write it, half 1 by s plus s by s square plus 36. Then you replace every s by, you look whether it is s plus 1 or s minus 1. If it is e to the minus, then this here it becomes plus. So since it is e to the minus t, this becomes s plus 1. So this is equal to 1 by 2, 1 divided by, this is s plus 1 plus s plus 1 divided by s plus 1 the whole square plus 36 is the final answer. Okay, so every term we get, we can perform the similar operation. All right, let's move on to the next problem. So here I'm going to consider f of t is equal to, this is 1 plus 3t into e to the 2t the whole square. Before proceeding further, let's simplify this. This is 1 plus 2ab, so 6t e to the 2t plus b square. So this is 9t square e to the 4t. Okay, so now the Laplace needs to be taken in separate form. So for 1, what is the Laplace? It is 1 by s. So next I need to take care of 6, right, t into e to the 2t. We'll get the Laplace as 6 into, I need to write the Laplace of t itself, right? So I'll write this is Laplace of t, but replace s by, since e to the power 2t, it is s, there positive means here negative, s minus 2, s should be replaced as this. Then, so let's calculate that. So what is this L of t? Laplace of t to the power 1 is 1 by s square. So this is equal to 6 into 1 by s square with s being replaced as s minus 2. So this is 6 divided by s minus 2 the whole square is the answer for 6t e to the power 2t. Similarly, I have another term to be added to this, that is 9t square e to the 4t. What should be its Laplace transform? So its Laplace transform will be 9 into, I have to apply Laplace of t square and replace every s by s minus 4. So this is equal to 9 into Laplace of s square is 2 divided by s cube. Okay, replace s by s minus 4. So we are going to get this as 2 into 9. So 18 divided by s minus 4 the whole cube. That's the answer. So now we'll write the final answer. That is, therefore, we have to club the answers together to get this answer. So this is 1 plus 3t into e to the power 2t, which is the question that has been asked, whole square, has a Laplace transform. Add all the three Laplace transforms we got so far. That is 1 by s for the first term, and the second term we got 6 divided by s minus 2 the whole square, and the last term is 18 divided by s minus 4 whole cube. This is the required answer. So whenever we have sum present over there, if you have a sum, you can definitely uh, find individual Laplace transforms and add, like we did just now. Okay, all right, let's proceed further. The next question is f of t is equal to t times cos at. So we know very standard term that cos at has the Laplace s divided by s square plus a square. Then I can see that this function is multiplied by t. So t into cos at should have the Laplace. Recall the property. When I multiply the function by t to the power n, I should multiply this with minus 1 to the power n. So minus 1 to the power 1 into d to the d by ds now, because d to the n by ds to the n, but n is 1, of the right hand side. That is, f of s is s by s square plus a square. This is what is the rule. Okay, so this should be equal to minus of, so quotient rule, so s square plus a square into differentiation of s, that is 1, minus s into differentiation of s square plus a square is 2s whole divided by, this is s square plus a square the whole square. All right, so this is minus of s square plus a square minus 2s square divided by s square plus a square. The sorry, this is not power 4, my mistake. This is a square. So rearranging the terms, because there is a negative sign on the outside of the bracket. So minus 2s square plus s square becomes minus s square. Minus of minus becomes s plus s square minus a square whole divided by s square plus a square the whole square. Okay, this is the required answer of the Laplace of the given function. Okay, next question is f of t is equal to t square into sine 80. So let's start with the sine function, because this looks like t to the n into f of t for us. So for f of t, we should know what is the Laplace transform. So therefore, we know that if you have sine 80, what is the Laplace? Laplace of sine 80 is a divided by s square plus a square. So when we know this, right, we can definitely write this implies t square into sine 80 should have its Laplace minus 1 square into, this is d square by ds square, double differentiation of a divided by s square plus a square. So this means minus 1 square is plus 1. First, I retain 1 d by ds and apply a d by ds to this term. What happens? So this is denominator is s square plus a square into differentiation of a is 0 minus s square plus a square differentiation is 2s whole divided by s square plus a square the whole square. So I'm supposed to apply two differentiations, but I keep one of them as it is because I can apply only one at a time. So d by ds of this is minus, so there is a outside, sorry, this is 2s into a. Okay, this is minus 2as divided by s square plus a square the whole square. All right, so this now I can apply the second differentiation to this. So that means the denominator, let's keep the denominator first. So denominator is s square plus a square the whole square into derivative of the numerator is minus 2a, right? Then plus, we are writing the denominator as it is. Okay, so that means it has to be minus of minus is plus, so we have 2as as it is into derivative of the denominator is 2 times s square plus a square into derivative of s square plus a square will be a 2s whole divided by this is s square plus a square whole power 4. Okay, this can be written in the following format. We can see that there is a 2a into s square plus a square common, right? So I'll write that 2a into s square plus a square. If I take this out, I'm left with the first term is 4 times, so 2a has gone, so 2 into 2 is 4, s into s is s square, this is a positive term, minus this is s square plus a square whole divided by s square plus a square power 4, out of which one of the powers will get cancelled. You are left with 3 over there. So this is equal to 2a into, so you can see that 4s square minus s square is 3s square minus a square whole divided by s square plus a square whole cube. Okay, so this is the required answer. All right, then let's go to the next question. So here, let's take the f of t is equal to 1 minus e to the minus at divided by t. Right? So as soon as I see divide by t, right, we have a property that is integration on the right hand side. Right? This property should be integration of S domain. So let's start with the 1 minus e to the minus at and let's calculate its Laplace. That is 1 is 1 by s minus e to the minus at is 1 by s plus a. Alright, so therefore if you write 1 minus e to the minus at divided by t, its Laplace should be integration of s to infinity, right? Whatever is there on the right hand side, that is 1 by s minus 1 by s plus a ds. So this is very standard now. 1 by s is what? It's simply log s integration minus 1 by s plus a will have log s plus a, right? So I should substitute from s to infinity. All right, so now let me club them together. So this is equal to, it's simply log of s divided by s plus a from s to infinity, right? So when I want to substitute infinity to this, right, this is equal to, so I'll keep it in this fashion, log of, so I try to s divided by, I try to take out a s, 1 plus a by s with s equal to infinity, this is the first term, minus this is the log of, put s is s only, so s by s plus a. But you see that this s cancels when you put an infinity to this, log of 1 divided by 1 plus 0, so log of 1, the whole term becomes equal to 0. So this is, first term is 0 minus this is log of s by s plus a. So s by s plus a being negative log, I can write it as log of, this is s plus a divided by s is the required answer. Okay, very straightforward. I just have to manipulate the logarithmic terms properly. Okay, then next one, f of t is equal to, say, cos at minus cos bt. So if this is the function, whole divided by t, I have whole divided by t. So this means as soon as I see this, since there is a divided by t, it has to be the property called integration on the right hand side, or integration of s domain. So let's start with the numerator part, that is cos at minus cos bt is going to have its Laplace transform as, since it is a cosine function, s by s square plus a square minus s by s square plus b square. So this implies, if you have cos at minus sin bt whole divided by t, then the Laplace transform should be integral 0 to infinity, this is s by s square plus a square minus s divided by s square plus b square ds, right? So you can see that this integration is very standard. So I'll take half, half, half of, this is, there is half for both the terms, log of a square plus a square minus log of a square plus b square, right? Substitution should happen from 0 to infinity, not 0 to infinity, s to infinity. Okay, so please correct, this is s to infinity, s to infinity. So I should substitute s to infinity for this. So this is equal to half log of, right, both the terms I can club together, s square plus a square divided by s square plus b square. Should substitute s to infinity. So half I'm going to bring inside the term, right? But before that, anyway, let's simplify half of. So first, when I want to put infinity, I cannot put the infinity as it is to the log term, because in numerator and denominator both will become infinity. So for that reason, I'm going to make a small modification. Take s square outside. So this is 1 plus a square by s square whole divided by, take s square common in the denominator, this also becomes 1 square 1 plus b square by s square. To this I can put s is equal to infinity minus the next term, that is log of, put s to s, it means it remains as it is, s square plus a square by s square plus b square. So I know that this term is 0, log of 1, that's why it's going to be 0 now. So I'm left with, this is minus half of log s square plus a square by s square plus b square. So you can see this minus half goes inside by taking a square root and exchanging the numerator and denominator. So this can be simply written as log of this square root, because of term being multiplied by half, and the minus makes inverse as the term inside the bracket, that is s square plus b square by s square plus e square. So this is the required function. Okay, let's move on to the next problem. So f of t is equal to integral say 0 to t, this is t cos at dt. So we know that, I'll start with the t cos at, right? We already have proved something, that is, so if you have the function as, this is the function, if you have a function and you know its Laplace, already we have proved this in the previous section, that is s square minus a square whole divided by, this is s square plus a square the whole square. Then, right, if you integrate on the left side, this is integral 0 to t of this function t cos at dt. What happens to the left right hand side? You divide the function by s square minus a square whole divided by s into s square plus a square whole square is the final answer. Okay, then let's go to the next question. F of t is equal to integral 0 to t e to the 2t, this is sine at divided by t dt, right? So anyway, I can see that there is a sine function, it gets divided by t, then, right, there is e to the minus function. Okay, so now, so let's start with the function, let's start with sine at by t. So how do you find sine at by t? I should apply, I should start from sine function. So sine at will have its Laplace a divided by s square plus a square. Correct? Now, what do you do for sine at divided by t? Because step by step I can do that, right? So this means integral, this is s to infinity, this is a divided by s square plus a square into ds. So this is a standard integral, right? This is a as it is into, so a by s square plus a square is 1 by a into tan inverse of s by a, right? So should be substituting s to infinity. Okay, so this means it is equal to tan inverse of, when you put s as infinity, it is this, minus tan inverse of s by a. So this means tan inverse of infinity is what? It is pi by 2 minus tan inverse of s by a. So I know that pi by 2 minus tan inverse becomes cot inverse. So this is cot inverse of s by a. This is what? This is the Laplace of sine at by t. I have another term coming up. That is, once you have this, if I want to multiply this function by e to the 2t, therefore, in the next step, to this function I'll apply e to the 2t. So, therefore, e to the 2t into the above function, that is sine at by t, will have the Laplace, right? The same function, that is cot inverse of s by a, with s being replaced as s minus 2. Why s minus 2? Because it is getting multiplied by e to the 2t. So that is equal to cot inverse of s minus a divided by 2. Not 2, a I guess, sorry. S minus 2 by a, my mistake. So this has to be s minus 2 divided by a. So this is the function. Now if you want to integrate this, I should have divided the right hand side by 2. Therefore, the final step, this is integration, that is 0 to t, the given function e to the 2t into sine of at divided by t into dt should be equal to, right, divide the whole function by s on the right hand side, right? This should have its Laplace 1 by s into cot inverse s minus 2 divided by a is the required answer.